I myself, Mudit Jain, BIM thinker. We often hear about dynamic facades, buildings that move, rotate, or transform through the day. And honestly, people love dynamism. It makes building stand out. It creates identity. Technically, such systems are possible. But the real question is, how do we make them practical, controlled, and meaningful? Instead of moving entire building skins, what if we introduce a subtle layer of motion by rotating vertical fins? Simple, controlled, buildable. Now imagine if the movement is not random, but linked to actual movement of sun. So the building doesn't just look dynamic, it responds. In this presentation, I will show you how we structure that idea using BIM, mathematical logic, and mechanical grouping. Let us explore. On the left, a static system. The sun moves from morning to evening. The fins do not. So shading performance keeps changing, but the facade remains fixed. On the right, dynamic fins. The sun position changes and the fin angle responds. Instead of designing for one-time condition, we design for the entire solar cycle. The difference is not movement, the difference is control. This is not animation, this is model-driven logic. Here the time setting is changed inside the sun study. Each time the sun angle changes, a Dynamo script recalculates the required fin rotation. The fin color changes based on angle, so we can visually verify the response. If certain fins are not directly exposed to the sun during a particular period of day, those fins are remain at zero rotation for that duration. So the system does not move unnecessarily. It responds only where exposure exists. At the same time, the logic is flexible. The same framework can be configured in reverse, allowing maximum sunlight and natural daylight penetration when required. This is BIM connected to computation. Geometry is not drawn manually. It is controlled through parametric logic. So the facade is not a static object. Rather, it's a responsive system. Behind this rotation is a simple mathematical principle. As the sun moves across the sky, its angles follows a predictive curve. We use this relationship similar to a sine function to map time to rotation. So instead of arbitrary movement, each fin angle is mathematically derived. Time becomes input, angle becomes output. Now geometry alone is not enough. It must translate into a mechanical system. We divided the facade into modules. One module equals 4 fins. Each module uses 2 motors. Motor A controls two fins. Motor B controls next two. Instead of 172 independent motors, we structure movement in logical groups. This allows controlled wave motion, reduced load per actuator, and simplified maintenance. Design becomes buildable. All angles calculations are structured in sheets. The first layer computes fin angles based on time. The second layer translates that into mechanical rotation values. The third layer integrates everything into a master control sheet. So what you see in the model is backed by structured traceable data. This means the facade logic is not visual only. It is programmable. This entire system works in three layers. Layer 1, solar logic. Layer 2, mechanical translation. Layer 3, structured data integration. BIM becomes the central coordination platform. From sun position to motor movement to control logic. This is not facade modeling. This is system design through BIM. Systems like this are never the work of one discipline. It requires alignment between multiple experts. A facade consultant to define performance intent and envelope behavior. A structural engineer to validate wind loads and dynamic forces. A mechanical motion engineer to design shafts, bearings, and torque requirements. An electrical engineer to ensure power distribution and motor integration. An automation or PLC engineer to translate environmental inputs into controlled movement. Now here is the important part. With the exception of automation, and in some cases a motion specialist, most of these consultants are already part of typical project team. So adopting a controlled movable fin system does not mean adding layers of consultants and extending delivery timelines. It means aligning the expertise that already exists around a smarter facade strategy. And at the center of it, a BIM thinker. Someone who connects geometry, environmental data, mechanical logic, and system control into one coordinated framework. Because this is not about motion for the sake of motion. The goal is not just movement. The goal is measurable performance. When design, mathematics, and mechanical logic align, we move from architecture to intelligent building systems. Thank you.
If you like the video, please like, subscribe the video and channel. This will encourage me more. Your comments will help in refining the content and defining the intent.